All right, so back here at Lawrence's, and what we're going to do is create a roast potato microbial brew. Now there's lots of different ways that we can actually brew up the biology for our soil. I find this is one of the simplest. What I like about it is we don't need an aerator, we don't need the addition of any other technology or electricity. We can just get some ingredients, throw them together, put them in the bucket, and let nature do the work. So the three main ingredients that we need is a couple of handfuls of good vermicompost, so worm castings. So a few weeks ago, actually a month ago, we set up the worm farm, and this is what we've been able to get out of it. So we've got a couple of good handfuls in there. The other thing we're going to be using is molasses. Now this one is specifically unsulphurated, so there's no sulfur in it. So as you can see here, you've got to make sure that it's got no sulfur, because sulfur will kill microbes, and we don't want to do that. So this is the sugar source for the production or the mass reproduction of the microbes. And the last part is simply roast potato. Now the roast potato is the starches, and the reason you roast it first rather than just using raw is it actually releases those starches and those sugars, so it's available to the microbes. So the first thing we do is we get a couple of those small to medium roast potatoes, okay, and then we just crush them up. So we just mash them up. Now you can either do this in your kitchen or whatever. It's a bit of a, in my household anyway, it's a fight to see who gets the roast potatoes first, myself or the kids, because they actually quite like eating them. So I always try and keep a couple aside when I'm making one of these brews. I swear sometimes I spend more time in the kitchen doing this than I do out in the garden. All right, so that's mashed up enough. So what first thing we do is we get the worm castings. All right, and we just tip it in.
So how much water again?
So there's about 20 litres of water.
Right.
All right, for this. So a couple of handfuls, good handfuls of vermicompost, and 20 litres of water. Okay, so we've mixed that in. Then we open up the plastic bag or whatever container you have with your roast potato, and we put that in, and then we just mix it up as well. As you get it through, you get it in between your fingers, so you can give it a bit of a mash while it's in there. That's releasing the starches and the sugars to get in there and feed that brew. Now, if you want to come up and have a bit of a look, you can see it's actually changed colour significantly. So that was just rainwater initially. So that's got the worm castings in it and the potato.
So
and
we use rainwater.
Rainwater, unchlorinated water is what you want to use. Excuse me a second, I'm just going to use my teeth. Unchlorinated water, because the chlorine will kill the microbes. And the other thing that they're putting in water now is chloramine, which is a bit more savage than chlorine, and that kills microbes too. So rainwater is the best. Now it's a couple of tablespoons of the molasses that goes in. So what I do, I'm you know, it's just one, two, that's it. A couple of good squirts, and then again we mix that in. So you can do figure eight or circles or whatever else. We want a bit of agitation to get into that. All right. Now that's all we need to do. Now the other thing we need to do is just to cover it. Now you don't have a hard covering on this. It might be a sheet or something along those lines, just to keep the insects and stuff out of it. And we leave that sit for 24 to 48. Yeah, that'll do. That'll be fine. 24 to 48 hours. Right. So we just cover that. We leave it for 24 to 48 hours and it's ready. Then you take that out and you water it down depending on what you're using it for. So it's usually about 1 to 5, 1 to 10, and you water it out on your vegetables or out on your, you know, your mulches to really kickstart the breakdown of those, that sort of thing. This is not about nutrient, this is about brewing biology. So we're introducing biology to the system. So, you know, say for example, you've got a landscape like up here, and you can see all that wood chip. To really build soil, putting the wood chip on, and then putting that brew on top of it so the microbes can start consuming it, turning it into soil.
Ah, okay, nice.
Yeah, so we're closing the loop as much as we can.
Right, right. So the worms eat the microbes.
Yeah.
You say? Yep.
Yeah.
Okay.
So when the microbes are there, the worms will arrive,
Aha.
and they'll help break that down even further.
Right.
So if you want to look at it, if you're not certain whether you've got the biology in your garden, whether it be fungi or bacteria, if you're digging through your garden and you find worms, you know you've got bacteria and fungi because they're there. The worms are there to consume them.
Okay. Okay.
You know, so the more worms you've got,
Yep,
the healthier your soil is going to be.
And once it passes through the gut of a worm, it
inoculates it even more.
Aha.
So it just keeps adding to the system. So, you know, and something as simple as, in this instance, throwing some wood chip down, brewing up a bit of biology from the worm farm, and that just starts that process. So we can speed things up exponentially by these little processes.
So it's not adding more like nutrients, like minerals and all that.
This isn't.
Yep.
The starches from the potato
Yep.
and from the molasses
Yep.
is about feeding the microbes.
So
we're
it's-
taking those couple of handfuls,
Yep,
there's
yep,
several
yep.
trillion worth of microbes in
Right.
those couple of handfuls,
Okay.
and we're breeding them up.
Right. And how does that benefit the plant?
Well, what it does is that the plant needs soil for starters,
Yep.
but the nutrients can only be given to the plant through the microbes.
The nutrients through the microbe. How does that?
So this is going to be a big lesson. All right, in short,
Yep.
the plants can't take up the nutrient on their own.
Uh-huh.
All right, naturally in a natural ecosystem.
Oh.
So the bacteria and fungi,
Yep.
through their own processes,
Uh-huh.
consume the nutrient. They can't produce sugars. The plant, through photosynthesis, produces sugars. So they trade.
Oh.
So there's a bit of barter that happens.
Right.
And so the bacteria will need certain things to survive, certain sugars.
Yep.
And so it will barter with the plant on getting those sugars, and in turn,
Yeah.
the bacteria feed the plants the nutrients as well. Same with the fungi. That's a very big conversation short.
Wow.
But that's it in a nutshell. The thing is, though, if you break that cycle,
Yeah.
say for example the application of a salt-based artificial fertilizer,
Mm-hmm.
which the plant doesn't need to trade with the bacteria and fungi,
Yep.
all of a sudden the bacteria and fungi do not have access to those sugars.
So what problem is that
They
cause? Oh, they die.
Yeah, because they have no
Okay.
sugar.
Right.
They've got nutrient, but
what
they
hap-
have no sugars.
and what
They
hap-
need the sugar. The plant supplies the sugar.
Right.
The bacteria and fungi supply the food.
So what happens if the bacteria die?
Well, then the plant is solely reliant on what we feed it. It becomes dependent.
Right.
So, and when it's what we feed it, typically the fertilizers we feed are incomplete.
NPK.
Well, it's not just NPK. There are
Yeah.
trace elements in there
Yes,
as well,
yes,
but
yes.
it's never complete.
Right.
Whereas when the application of, for example, the wood chip, the compost, and other things, which is broken it down into more complete forms, and then the biology is feeding that to the plants. If the plant is more complete,
Yep,
then it's
yep.
going to have less health issues. If
Yes.
it has less health issues, it's going to be more
Yeah.
pest resistant. It's going to be healthier for us. Not only, I mean, if we grow something that's in soil that's deficient, and the plant is deficient, and then we consume that. What are we
Yeah,
missing?
true.
There is a
There's a
a
cost.
biological uptake.
Yeah.
Yeah.
Yep.
With that.
Well, it reminds me of our gut bacteria. Like if you eat culture food, you're getting a lot of beneficial bacteria.
The same, pretty much the same beneficial bacteria that's in the soil.
Yep.
It's the same bacteria in us.
In our gut, yeah.
There's a
yeah.
relationship there.
That's right.
and anyway, that's a really big conversation.
Yeah, because you just basically pick, like people in the past, they don't wash the vegetable in the chlorinated water, they just
Well,
pick
that's
it
right.
from the garden
Yeah,
and eat it.
yeah,
So
yeah.
there's a lot of bacteria. And a lot of those bacteria produce vitamin B12. Yeah.
There's a lot of stuff that's being produced
Yeah,
in it.
yeah.
But again, if the plant is incomplete, then it's not going to be doing it properly. It's going
nice.
to be more prone to pests and
Yes.
diseases.
Yes.
And then we look at it and go, typically we look at
Yep.
it and go, what can I apply to help deal
That's
with
right.
that pest?
Yeah.
When really, if we focus on the soil
Yeah.
and let the soil do the work, well, not only have we halved our workload, we get a better quality product from our gardens in the first place.
Thank you.
You're
Wow,
welcome.
wonderful.